Hey everyone, it is me, Miss B. And in this video, we are actually looking at some content from the 8th grade curriculum in Illustrative Math. So not the Illustrative Math Algebra 1, but yes, for my Algebra 1 class. So let's get started on this homework assignment. So our first job is to make sure that we justify our thinking as we answer each question and show work in order to earn our full credit. Well, you know me, I always show all of my work. So let's first solve each of these equations. Now I am going to make sure I show all of my steps. And I may not show all of my reasoning, but I am going to explain it. We have two sides to this, and we also have variables on both of those sides. So I have 2x on the right and 3x on the left. I always like to try to move my variables over to where the larger number is, because then I don't end up with negatives or having to divide by those. If you are less comfortable with that and you would rather move things around differently, go right ahead. That's just my preference. But to each their own. I always want you to do math in the way you're most comfortable, as long as it's still correct. So what I'm going to do here is actually first, we have a couple options. So you can start with moving your integers or your numbers, or in this case, the constants here of 1 and 10, or you can start dealing with your variables of 3x and 2x. I like to move my whole numbers, and then I like to move my variables, and then I like to, solve for that variable. So let's do that part first. I'm going to, and since this is adding 1, I'm going to subtract 1 from both sides. And I'm lining that up with the actual part I can subtract it from and making sure I have 1 on both sides, so this is a balanced move. So it's going to leave me with 3x on the left. 2x on the right here is not going to change. It's just going to come down and stay the same. But 10 is going to be able to subtract 1, and it's going to become a plus 9. Now we're going to move, so I'll change my color here, and I'm going to move this 2x. I'm going to subtract 2x over here on the right, which means I have to do the same thing on the left. And when I subtract it on the right, it cancels or it goes away. And I didn't show that, but that actually happens with this one also, and that's why I made that move to begin with. So now on the left, 3x minus 2x leaves me with just 1x. Or x, the 1 is oftentimes invisible, but I'll just write it out there just so that we're okay with that. And then on the right-hand side, the 2x and the negative 2x canceled out, so 9 just comes right on down, and I get 1x equals 9, or just x equals 9. Hopefully you were able to see all of my reasoning along with me explaining it. I'm going to do some of these other ones a little bit faster and not explain each step as in-depth as I go, but you'll still see how I solve each question. So divide it down the center. Going to add 4. I want a skinnier marker. Add 4. In order to make that cancel out, I'm going to line that up here. What we have left is just 3y. And then 6 plus 4 is 10, minus 2y. Try to show my work in blue and then each step in red, I guess. Okay, so I want to add 2y and add 2y, and that will move y over here from the right. 3y plus 2y makes 5y. And then we just have 10 over here on the right. My next step is to divide each side by 5, and then that's going to leave us with y equals 2. And that's the answer to this question. So we had 2 equations to solve. The first one we had x equals 9, and the second one we had y equals 2. And making sure that I show all of my work so that anyone who looks at this could see what I did. So let's move to question 2. Claire is solving an equation, but when she checked her answer, she saw her solution was incorrect. She knows she made a mistake, but she can't find it. So where is Claire's mistake, and what is the solution to the equation? So let's look at Claire's situation here first. It looks like she's keeping her equal signs balanced, so she kind of has her line straight down the middle there, so that's all good. Um, and it's also looking like she's going to have to, or not have to, but it looks like she is distributing here to multiply some things out. So we're going to check her work and see on each side. So over here on the left, 12 times 5 is, oh, you see a mistake already. Go ahead and check with your calculator if you want, but 12 times 5 is 60. So that should be 60. And then 12 times 2 is 24, so that works, but we should have 60 plus 24y. Now on the right-hand side, we have 4y, and then minus all this stuff in parentheses. If you ever come across that, you can imagine that that minus is like a -1, and you can distribute that to each of the pieces here. So that would create -5, so that's good. But a -1 times a -9y is going to make a positive 9y, not a negative. So we have two mistakes here already, one on each side. So she was supposed to multiply 12 times 5 is 60, and 12 times 6 is 72. And then her negative didn't get multiplied with her -9y or her -9y. So right away from the get-go, I see some mistakes. So let's not keep going. Let's actually just revise and fix up Claire's problem. So she should have 60 plus 24y is equal to 4y. That part was fine. The -5 is fine, but this should be plus 9y. So now this is the part we're going to solve. Take my line here. Keep things even. Okay. First thing I'm going to do is just kind of combine some things on the right. So the left-hand side I'm going to leave alone. This is still going to stay 60 plus 24y. We're just going to rearrange this so I can do the 9y. I'm going to combine that with the 4y. And since they're both positive, this is going to make 13y. And -5 is going to stay -5 or -5. Okay, so now I can start moving stuff around. I'm going to subtract 60. Make sure I'm lining it up with its like term. This will leave 24y equals 13y, and then -5 minus 60 is going to make -65, or -65. Now let's subtract 13y from both sides. And on the right-hand side, it's going to go away. On the left-hand side, 24 minus 13, I believe, is going to give us, it's either 11 or 9, and sometimes my brain doesn't know which direction to go with it. So 24 minus 13, it is 11, so I was right the first time. So we would have 11y is going to be equal to -65. Okay. 12 times 5. Just making sure I didn't make any mistakes here, because that's very possible. And 24y. Okay. All right. So this leaves us with one last step. Divide both sides by 11. And that would cancel, meaning we have y equals -65 over 11. Well, if we want to actually reduce this, it doesn't. You could write it as a decimal, but 65 over 11 actually does not reduce any further. So that would be as close as we can get it to our actual answer. So still not a lovely answer because she had negative 77 over 29, but definitely a different one. And just for visual, I'm going to highlight where her mistake was at here, these pieces that I crossed out. Because that's probably good for us to be able to see that. So we're going to move on to question 3, and we're going to solve and check our solutions. So I'll show the check step in here afterwards if I remember. Let's divide up our equal signs here. And now I have a couple options, but I see that I have 2 fractions outside of each of these. And what it looks like to me is those fractions, if I multiplied them through, I don't think the numbers inside are going to reduce to nice numbers with them. Like 2 over 9, that's not going to reduce, and 16 over 9 is not going to reduce. So if I was to multiply this with these pieces, I would not get nice fractions. And same with 1/3, if we were to multiply that here, we wouldn't get fractions that end up reducing with each other. So what we can actually do is multiply both sides of an equation by something to get rid of these fractions instead. Now, it does just so happen that I can use 9, because 9 will get rid of the 3 and the 9 altogether. And sometimes this is called fraction busting, meaning we are trying to break up all of these fractions and use whole numbers only instead. But this is doing a balanced move of multiplication. So what I am going to show is if I multiply this entire thing on the left, I'm going to multiply this whole thing by 9. And because this 1/9 is already multiplying here, it is just going to take that with it. So I don't have to distribute my 9 here and then all the way through. This 1/9 is going to take it all the way through when it multiplies. So this is just going to be considered one term. But multiplying by 9 is actually like multiplying by 9 over 1. And you'll notice, oh, look at that. My 9 and my 9 can cancel each other out. So all we would have left on the left side here is just 2m minus 16. But it's going to be very different on the right-hand side, because when we multiply this by 9, or like 9 over 1, 9 over 1 times 1 over 3, I'll actually write this a little smaller off to the side. 9 over 1 times 1 over 3, these aren't going to cancel completely. You would end up with 9 over 3, which is the whole number 3. So that change is going to happen when we multiply this with our 1/3. And just like on the other side, that 1/3, as it multiplies through, is going to carry that number with it. So we don't have to multiply again through all of those. It's kind of just considered one term. So when we multiply on the right-hand side, we'll end up with 3 and then the stuff inside. So 2m plus 4. And now we're actually going to do that distribution. That'll be my next step, is to distribute through and see what I get on each of those sides there. So left-hand side will stay the same, 2m minus 16, and this will be equal to 3 times 2, which is 6m, and 3 times 4, which is 12. Okay, now I did tell you my preference was to kind of move my variables to where the larger one is at. And in this case, the larger variable, or the one with the larger coefficient, is on the right. So I'm going to try to move everything with an m to the right and everything without an m over to the left. So we are going to get rid of the 12 then. So subtract 12, subtract 12. 2m stays the same, but negative 16 and negative 12 are going to combine and become even more negative. So we're going to have negative 28 or minus 28, same thing. And that's going to be equal to 6m. I'm gonna subtract 2m from both sides, keeping things balanced. So this would create negative 28 equals 4m. Last step is going to be to divide by that 4 because I want m to end up on its own, so I am intentionally dividing by that 4 to get rid of it. And what you'll have is that negative 7 is our value for m. Now, they did say to check my work and to include that, so I'm going to include my little check step here, and kind of show some work in this box. I'll make my box a little nicer and neater if I can. Yeah, I shouldn't have drawn a box. Limiting myself here. So let's start with a check, and I will write this one in purple, I guess. So check. So we want 1/9. And all we're doing here is we're going to plug in negative 7 for that value of m. So 1/9 times 2, and instead of 2m, it's 2 times negative 7 minus 16. Is that equal to 1/3 times, I'm running a little bit out of room, so let's actually just evaluate that, and then we're going to evaluate the other side. So 2 times negative 7, that's going to give us negative 14 minus 16, and then we want to multiply this by 1/9. So that is going to be 1/9 times negative 30. I believe this is going to be 3 1/3, or it's negative 30/9, which is the same thing as negative 10/3 if it reduces. So we want to check that our other information is equal to the same thing. I'm just trying to find a better place to put this so I don't run out of room for my other one. So maybe I will actually lasso this. We'll wrangle this over to the other side. And I can continue my check steps sort of underneath. I just don't want to crowd out my work for question B. So now what we want to check is the 1/3. So 1/3, 2m plus 4. Okay, so we got this answer here. We want it to end up being the same. So 1/3 to m plus 4. And we want to know what that equals. So this is 1/3 negative 14 plus 4. So I'm actually going to skip writing out every single step here. But 2 times negative 7 is negative 14. And if I add 4 to that, that just brings us back at negative 10. And this is just like negative 10/1. So if we multiply this out, we get negative 10/3. Since both sides give us the same value, we can say this is correct. So checking can be setting things equal and plugging things in to make sure it works, or just individually checking the value on each side. So our next one doesn't have nearly as much, and it might be easier since it doesn't involve fractions. I'm going to take the approach for this one since I have whole numbers on the outside. I could do some division. I'm just going to multiply things through and work it out. So I am taking this entire thing, the negative and the 4, and distributing it here while keeping my sides equal and balanced. And I'm going to take this positive 4 and distribute it also. So I actually am keeping everything balanced because I'm not changing the value. I'm just sort of rearranging things or distributing things through. So negative 4r minus 8 is equal to 8 minus 8 r. Okay, so now I'm dealing with some negatives. Um, and like I said in the previous question, I like to move things to the side with the largest coefficient of our variable. And in this case, -4 is bigger than -8. So I actually am going to move things over to the left. Even though 8 is a larger number, the negative version is not. If you have a larger negative, that means it is smaller. So let's move those things around. Okay, let's add 8r to both sides. And you'll notice I'm only putting things with variables underneath the other things with variables, so that way they can either cancel out or combine. You would not combine the 8 with the other 8 on the left-hand side. So over here on the left, -4 and +8 is going to give us a +4r minus 8, and that's going to be equal to our +8. Add 8 to both sides. That will cancel here. So you'll have 4r is equal to 16. And last step is we will divide both sides by 4 and have that r is equal to 4, because 16 divided by 4 is 4. Now, this will be a little easier to check. I can just plug everything in. So -4 times, instead of r, we're going to put 4 plus 2. And we want to know, is that equal to 4 times 2 minus 2 times 4? So left side might be a little easier here. -4 times 6. And on the right-hand side, +4, I'm going to just work from the inside out. This is going to be 2 minus 8. 2 minus 8 is -6. So is -4 times +6 the same as +4 times -6? They absolutely are. They're both going to give you -24. So this is the other version of doing a check step, is just evaluating each side without moving things from side to side. So every step I did here was maintaining the value on both sides. I was just combining things. As opposed to this other side where I just plugged things in and worked them out individually to check. You can also do this here and check that your answers work this way. But that means that r is equal to 4, and that works. So that's onto the back side then. We have question 4. Elena said the equation 9x plus 15 is equal to 3x plus 15 has no solutions because 9x is greater than 3x. Do I agree with Elena, and explain your reasoning? So let's actually just try to work it out. So I'm going to write out this question here. 9x plus 15 equals 3x plus 15. I'm going to split my equal sign here, so I have the same value. And now I am going to try to move all of my x variables to the left, because that's where my larger number is. I have the 9 versus the 3. And then I'm going to try to move all of my whole numbers or my constant numbers over to the right so that I have all the numbers on one side. So starting off, let's subtract 3x from both sides. That will get rid of this here. And on the left, this is just going to create 6x plus 15. And we're going to say this is equal to 0. So just a positive 15 left on this side. Okay, so all of my x's are on the left. Now let's subtract 15 from both sides, because I want to get rid of this one here on the left. And if I subtract 15 over here, this one is also going to go away. So we'll just end up left with 6x is equal to 0. because when we subtract and the numbers are opposites, we're just left with 0. I can treat this as if it was any other number, and we can still do our one last step, which would be to divide both sides by 6. And when we do that, is it possible to divide 0 by 6? Well, yeah. If you have nothing and you need to split it between 6 people, they all get nothing. So I disagree with, was it Elena? Elena. I disagree with Elena because even though 9x is greater than 3x, I still think that x equals 0 could be a solution to this. Because if you multiply something by 0, it's going to go away. So 9 times 0 would make 0, and 3 times 0 would make 0, and all you have left is that positive 15 equals positive 15, and we know that is a fact. So it works out even if we just do our check that way, but I'll leave that visible on my paper. That is going to bring us down to number 5. You know what? Actually, let me put my reasoning here. So I'm going to say I disagree. X can be equal to 0. And x being equal to 0 doesn't mean it's not a solution. It just means that 0 is the solution. So we're saying that x can be equal to 0, which is a solution. Because a solution is just a number that makes both sides equal to each other. And if we used 0, that would work. So then that brings us to question 5, where I have 4 lovely large questions, and wonderfully enough, they're not asking me to check my work, so we are just going to do some practice here. So divide these sides up. I'll make that line longer later if I need to. And I am going to start by distributing, but I am going to say that this is a -1 in order to help me distribute. So we'll distribute the 12 to the 5 and the 2y, and we're going to distribute our -1, not the 4y. We're going to distribute the -1 to both the 6 and the -9y. So 12 times 5 is 60, and 2 times 12 is 24. Then over here, we're going to have 4y. -1 times +6 would make -6, and -1 times -9 makes +9y. So I'm going to leave the left side alone and just combine like terms on the right. 4 plus 9 makes 13y. Now I get to move things around. Let's subtract 60. So 24y equals 13y minus 66. Let's subtract 13y from both sides. This would give me 11y is equal to -66. And our last step is going to be divide both sides by 11. And we are going to get that y is equal to -6. And that's part A. Let's move on to our next one. And obviously feel free to pause me and rewind if you need to see more of that work. I'm going to move on to the next one. So I am again going to do some of the distribution here first. That way I'll make things a little easy for myself. 3 multiplies with both of these in here. 2 is going to multiply with both pieces in here in this group. And -30 is just hanging out there by itself. Doesn't need to do anything right now. So we're going to end up with 9 minus 9x equal to 2x plus 6 minus 30. I'm gonna leave this side alone for right now and just combine all my like terms on the right. So this is gonna be 2x minus 24. Okay, and so my bigger value for my variable's coefficient is going to be on the right because I have -9 versus a +2, and positive will win every time. So I'm going to move my numbers to the other side or get them out of the way. And by lining this up under the regular 9, not the 9x, I can see it's a +9, and I'm adding 24 to it. So we're actually going to get, which is going to be 33 minus 9x, 2x, and then we will have to add 9x to both sides in order to move it here. So we'll end up with 33 is equal to 11x. And if you notice the pattern from the last one, when we had a duplicate number and we divided by 11, it gave us a whole number here. That's going to be the same thing. We're going to end up with +3 is equal to x when we divide both sides by 11. And that's A and B. Let's go down to question C. This one deals with some fractions, but in a slightly more different way than we saw before. Now, these are different because one of these has a numerator. So I actually have a number on the top in this fraction right here. But that's okay, because in order to get rid of a fraction, if I just got rid of the denominators, these would become whole numbers. So we're going to do that. And since our denominator is the same, we are going to multiply every single thing that needs to, at least, by 2. So, or by 2 over 1 to make it cancel. So we're going to take this left side, and I'm going to multiply this by 2. And on this right side, I'm going to multiply this by 2 also, but I'm only going to need to multiply the fraction here because this part is going to distribute and take it through the parentheses with it when it goes. But for this one, this needs to go through completely because nothing else here is grouped. So slightly different, but 2 times here and 2 times here. So what's going to happen with the one on the left is that the 2 and the 1/2 will cancel and we'll just have x, which is what we wanted. It no longer has a variable, or not a variable, it no longer is a fraction. And then 2 times 6 is 12. And I should have put my equal sign divider line. Now, the 2 that we multiply on the right-hand side with the 3 over 2 is just going to cross out the denominator, and it's going to leave us with the whole number 3. So we'll have 3, and then this is what's going to multiply by x plus 6. And so that's, since that's already doubled from 3 over 2 to just 3, now that one can distribute through on its own to its other two pieces. So x plus 12 will remain the same, and that's going to be equal to 3x plus 18. Okay, this is looking a little more normal. Let's subtract 18 from both sides. So we will have x minus 6 equals 3x, and I will subtract 1x from both sides. Now, if you're ever just subtracting x, I don't want you to think it's the same thing as dividing by x. 3x minus x is 2x. So it's not just taking the x off of there. This is saying there are 3 x's here, like x and x and x, and taking one of them away would still leave us with 2. So, easy mistake to make that I don't want you to wind up making. Because now we have one last step, which is to divide both sides by 2. And when we do that, we are going to get that x is equal to -3. And that's our answer. And we have one last question here. A little bit of a long one, it looks like, but that's okay. We can do it. We're just going to make a big long dividing line here and probably move it into place because that's bothering me that it's not. There we go. Okay, so in this one, I got numbers floating around all over. And if you're having a hard time with organizing your numbers, I suggest using a system where you either like underline or circle or put shapes around them in order to identify your like terms. And if it has a sign in front of it, the sign is going to come with it. So I'm going to use a highlighter here, and everything that has a B on it, I'm going to highlight in green. Now I said the sign comes with it, so for 5B, the negative sign comes with. And for 8B, I am also making sure the positive sign comes with. Now I'm going to use blue for the other numbers here. I see I have +8 and +3. Sorry about that. My microphone shut off on me, or my recording shut off on me. Either way, I don't remember which one it was. Um, but now that I have all of my like terms identified, I'm just going to combine the ones that are the same color because those are the ones I'm able to add with each other. So my green pieces here are going to create -3B, and my blue pieces here are creating a +11. This is going to be equal to, and on the other side, we're going to do the same thing. The green parts, well, it's just going to be 8B, so there's only one. But the blue pieces are going to combine and make -18. And from here, I can just solve it the way I normally would. I can move some pieces around. But highlighting or underlining or putting squiggles or boxes around them, just ways to identify which ones go with each other can help you organize your math here. So I like to move my variables to where the positive or the largest coefficient on my variable is. Since 8 is positive, it's bigger than -3. So let's do that by adding, oh, I like to show my work in red. That's right. Let's add 3B to both sides. So that'll leave us with just 11 on this side, and that's going to be equal to 11B on this side, and then the -18. We can then add our 18 to both sides. Whoops. Add 18, add 18. And then that will give us 29. And that's going to be equal to 11B. Let me double check my work, just because that seems like a number that doesn't quite work out, and I want to make sure that I'm doing this right. So -3, because -5 plus 2, we're good there. If I am adding 11, so 8, 9, 10, 11, I'm okay on there. 13, oops, 13, 14, 15, 16, 17, 18. Yep, that works for -18. +8. 8 adding 3 gives us 11. Yeah, okay, this is correct. It's just sometimes things don't work out to whole numbers, and a lot of times we're used to problems giving us whole numbers as answers. But our one last step here is going to be to divide by 11. And since this is not a repeated number, we're actually not going to get that it reduces. But we will have that b is the same as 29 divided by 11. If you want to make that into a decimal, you can, but yeah. It's always good to get comfortable with these things. I just know that a lot of times on worksheets, they try to make them equal to whole numbers. So that should be it for this assignment. The next one is our next lesson, so thank you for sticking with me. And this has been the 8th grade content from Unit 4, Lessons 5 and 6, but designed for the algebra class.